So we're looking at part 1 of the final exam review. This first question says, the bottom of a ladder must be placed 3 feet from a wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? On your final, you'll have a picture of this, but in this case, I would draw a picture myself. So I have the ground, a wall, and then my ladder here. It tells me my ladder is 12 feet long, and then it wants it to be 3 feet from the wall. So how tall or how high up the wall does it hit? Again, this forms a right angle here, so we're using Pythagorean's theorem to solve this. That's a squared plus b squared equals c squared. Remember, these are my two legs, so my a and my b and my c is my hypotenuse. That's across from my right angle. So I'm just plugging in what I know. 3 squared plus b squared equals 12 squared. So that's 9 plus b squared equals 144. Take away 9, b squared equals 135, and then b is the square root of 135, which is about 11.62 feet. So that's how high up the wall it'll hit. Again, we're doing the same thing on question 2, except this time it says, how far from the base of a house do you need to place a 15-foot ladder so that it exactly reaches the top of a 12-foot wall? So my wall is 12 feet. I don't know my base down here, and I know my ladder is 15 feet long. So I'm taking a squared plus 12 squared equals 15 squared. So that's a squared plus 144 equals 225. And again, it doesn't matter if you use 12 for a or b. As long as you're solving for one of the legs, you'll get the same thing. Next, I'm going to take away 144, and I'm left with a squared equals 81. So to undo that square, I'm going to square root it. So a equals the square root of 81, which is a is equal to 9. So the ladder needs to be 9 feet away from the base of the house in order to reach 12 foot up the wall. Question 3 says, on the graph below, use Pythagorean's theorem to find the distance between the 2 points. This is where you need to draw your triangles. So draw in your triangle. Here I have my 2 legs, and I'm always looking for my hypotenuse, or my C. So I have a 1, and then again I'm counting the spaces here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the length of this is 10. So I have, again, a squared plus b squared equals c squared. In both of these problems, you're looking for the c squared. So I have 1 squared plus 10 squared equals c squared. That is 1 plus 100 equals c squared, or 101 equals c squared. And then c is the square root of 101, which is about 10.05. Doing the same thing over here. This is 1, 2, 3, 4, 5, 6, 7. Then I have 1, 2, 3, 4, 5. The legs are 7 and 5. So 7 squared plus 5 squared equals c squared. That's 49 plus 25 equals c squared. 74 equals c squared. C is the square root of 74, which is about 8.6. Question 4, we're just finding the measure of this angle. It's the blue, looking at it, I know it's acute, so I'm going to be looking at these inside numbers here. It looks like it's right at 40, maybe 1 tick less, so we're going to call that 39 degrees. For this one, looking at my second one, this angle looks obtuse. I'm still looking on the inside numbers. It looks like it's between 170 and 160, so I'm going to call it about 165 degrees. Remember question 5, this is all about complementary angles. So complementary angles are 2 angles that add up to 90 degrees. I know that because of this right angle here. So I'm just taking 90, take away 51, and that gives me 39 degrees. For B over here, same thing. I know this is 90, so this has to be 90. I have 90 take away 31, and B equals 59 degrees on my second problem. Question 6 is asking me to name each angle in 4 different ways. Remember, you can name it using all 3 letters, the number, or just the letter at the vertex. So angle EDC, angle CDE, angle 3, or angle D. You can do the same thing over here. Angle GFE, angle EFG, angle G, or angle 4. Question 6 says to find the missing vertical angles, and I'm given some of them over here, so I'm going to fill in those. I have 136, and then angle 3 is 44. Remember, vertical angles are congruent, so when they form the V's opposite each other, they're congruent, so that means angle 4 is 136, and angle 1 is opposite angle 3, that is 44. Do the same thing over here. I know angle 1 is 30, so therefore angle 3 is 30. And then if angle 2 is 150, I know angle 4 is 150. Question 7 is asking us to find the midpoints below our midpoint formula. That's where you take the, you find the middle between the 2 coordinates. So I'm going to say x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So our midpoint is technically an ordered pair. So I have 7 plus 9 over 2 for my x's, and for my y's I have 4 plus negative 1 over 2. That leaves me with 16 over 2, which is 8 for my x coordinate. Then I have 3 over 2, and we're gonna leave it as 3 over 2, and that is my y coordinate. Same thing over here. I have x1, y1, and x2, y2. x1, y1, or x1 and x2 I'm going to add together and divide by 2. Same thing with my y's. That leaves me with 7 over 2 and 5 over 2. So my ordered pair is 7 halves and 5 halves. Question 8 has us finding the measures of angle ABC. If angle ABX, so angle ABX here is 5x, and angle XBC is 3x plus 10, and that's this angle here. From this, I know that what the question should have told us is that it's an angle bisector, so I can set these two equal to each other because it cuts it in half. So I have 5x is equal to 3x plus 10. I'm solving for x first, so I'm going to take away 3x, it leaves me with 2x equals 10, divide by 2, x equals 5, and then I'm going to plug it back into my formula. So 5 times 5, it's 25 degrees for this angle, and then hopefully I get the same thing because it's a bisector, so it cuts the big angle in half, so I should get the same number on for angle CBX. So I have 3 times 5 plus 10, that's 15 plus 10, so that's 25. So altogether, 25 plus 25 gives us 50 degrees. Question 9 asks us to fill in the blanks about Pythagorean's theorem. Remember, that's a squared plus b squared equals c squared. The variables used for the legs are a and b, and the variable used for the hypotenuse is c. Question 10 asks us the opposite operation of raising a number to the second power. So I have something squared. To undo that, I would need to square root it. And then question 11, it asks us to describe how the volumes are related between a cone and a cylinder that have the same base and the same height. So if I have a cone, and again, this is just a sketch, and then I have a cylinder, and they're the same base, so they're the same width and the same height, what can I say about their volume? So if I were to fill up my cylinder over here with water, it would be greater than my cone because I'm missing all this space over here. My cone essentially would fit inside of my cylinder, so the volume of a cone would be less. Question 12 asks us to describe how the heights are related between a cone and a cylinder that have the same, this should say, base and the same volume. Again, in order for the cone to have the same volume as my cylinder, I would need the height to be greater because the cylinder is going to, if they're the same, from the question above, we said if they are the same base and the same height, the volume of the cone would be less or the volume of the cylinder would be more. So in order for the cone to become equal to the cylinder, the height of the cone would need to be greater. Question 13 is asking us to find the area of the following shapes. So for our area of our triangle, that is 1/2 the base times the height. So we're just plugging in our base and our height. That's 1/2 times 6 times 5. Half of 6 is 3 times 5. That's 15 feet squared. Same thing over here for this other triangle. 1/2 base times height. 1/2, my base is 16, my height is 13. Half of 16 is 8, so 8 times 13 gives me 104 feet squared. For our area of a trapezoid, so area of a trapezoid, that is base 1 plus base 2, so my two bases here, divided by 2 times my height. So that's 6 plus 9 divided by 2 times 4. 6 plus 9 is 15 divided by 2 times 4. Type that all in your calculator and you get an answer of 26 feet squared. And we'll do the same thing over here. So that's 13 plus 19. Those are my two bases divided by 2 times 10. 13 plus 19 is 22 over 2 times 10. So that's 11 times 10 to get 110 yards squared. So we're looking at part 2 of the final exam review. And question 1 here gives us a cylinder. It says it has a diameter of 6 feet and it is 31 feet long, and it wants us to find the volume. Again, it gives us the note to use 3.14 for pi. And then round our answer to the nearest whole number. The first thing I'm going to do is I'm going to refer back to my reference sheet I gave you, or your formula sheet, and on there it should tell you that the volume for a cylinder can be found by multiplying pi r squared times the height. It told me to use 3.14 for pi, and then it tells me, and then I'm multiplying it by its radius squared times the height. I know the height is 31 feet, it's 31 feet long, that's the same as the height. but what I don't know is the radius. Here, it gives me the diameter. Remember, to find the radius, it's just half the diameter. So our radius in this case would be 3. So I'm going to take that times 3 squared times 31 for my height. Simplifying that down, I have 3.14 times 9 times 31. Again, we're typing all of this into our calculator. And what you should get out is 876.06, but it asks us to go to the nearest whole number. So the nearest whole number is just 876, and it tells us to be sure to include the correct unit in our answer. This is volume, so we are going to have feet cubed. Question 2, we're going to use the same formula from before because this is asking again for the volume of a tank, a cylindrical water tank. So V equals pi r squared times the height, using 3.14 for pi. This time it just gives me the radius, so I'm taking 5.5 and squaring that times my height, which is 16. If I simplify this down, I have 3.14 times 30.25 times 16. Again, when I type all that in, you should get out, so when you multiply all 3 of those numbers together, you should, that will result in 1,519.76, but be careful on the directions. It is asking us to round our answer to the nearest whole number and then to include the correct unit in your answer. So the nearest whole number in this case is going to be 1,520 because of this 7 here. 5 or more, add 1 more, 4 or less, let it rest. But if I think about it, having 76 cents is going to be closer to $1 than it is to $0. So our final answer is 1,520 feet cubed because it is volume. Question 3 is asking us to find the volume of a cone with a height of 12 inches and a base diameter of 8 inches. Referring back to my formula sheet to find the volume of a cone, that formula is V equals 1/3 pi r squared times the height. I keep my 1/3. Again, it tells me to use 3.14 for pi. It gives me the diameter of 8 up here, and you can also see that down here at the bottom. Remember, your radius is half of that. So if your diameter equals 8, your radius equals 4. So times 4 squared, and my height is 12. Simplify that down. 1/3 times 3.14 times 16 times 12. What I do to find the 1/3 is I just type in my calculator 1 divided by 3. Then I multiply that times 3.14 times 16 times 12. And for this problem, it says do not do any rounding. I want you to round to 2 decimal places. And when you type that in all into your calculator, you should get 200.96 inches cubed. We are still working with units cubed because we are finding the volume. Question 4, we're using the same formula, V equals 1/3 pi r squared times the height. It tells us the height of the cone is 10, the radius is 6. Again, I'm just plugging this into my formula. Again, using 3.14 for pi, 6 squared times 10. Simplifying this down before I go to type it in my calculator. And when you multiply that out again, your answer, I want you to round your answer to 2 decimal places. And you should get a final answer of 376.80 feet cubed. So we're looking at problem number 5 here, and it gives us a circle below with it saying KE is the diameter, and that JH intersects the circle at E, and that line IF intersects the circle at D and E. So it wants us to give a chord. Remember, a chord is a line segment that touches the two sides of a circle. So here I see two chords. I see KD, and then I also see DE. So either one of those listed would be fine. Remember, they're line segments. A secant line, if you refer back to your circle vocabulary chart, a secant line is a line that goes all the way through a circle. So in this case, that would be line FI. And then lastly, give a tangent line. That's a line that touches a circle. And in this case, that's going to be HJ. Question 6 gives us the equation of a circle, and it asks us to find the center and the radius and then graph the circle. So if I look at my equation here, remember my original equation is x minus h squared plus y minus k squared equals r squared. So I'm going to use my h and my k are my centers. Since it's a +1, technically my center is at -1, and then my 2, so -1, 2 is the ordered pair for my center. That right there. And then my radius, I'm just going to take the square root of 25, that's 5. So my radius is 5, so I'm going to count up 5, down 5, to the left 5, and to the right 5 to plot my 4 other points to then sketch my circle. Once I do that, I can just sketch it. Again, this is just a sketch. It does not need to be perfect. Question 7 asks me to translate the following figure 7 units to the left and 4 units down. My coordinate for my original figure is 2, 3. So when I translate it 7 units to the left and 4 down, I'm going to go over 7. So 1, 2, 3, 4, 5, 6, 7, and then down 4. 1, 2, 3, 4, and we'll have a point there. So my new ordered pair is -5, -1, and then from here I can go over 3 and make the other point, and then have my new translated figure. Again, I'm translating this triangle 4 units to the left and 4 units up. So from each point, I'm going to go 4 to the left and then 4 up. There's my first point. Again, 4 to the left and 4 up. 4 to the left and 4 up. That is question 8. You're going to skip question 9 and 10. Question 11 asks us to find the area of a circle whose radius is 8 yards. Remember the area formula, and this is on your formula sheet. This area is pi r squared. Again, we're using 3.14 for pi. It gives us the radius, so we're taking 3.14 times 8 squared. So that's 3.14 times 64. It tells us not to round our answer. I want to go to 2 decimal places though, and that should give us a final answer of 296 yards squared. Same thing for question 12. Same formula, area equals pi r squared. Tells us the radius is 9, use 3.14 for pi. So that's 3.14 times 81, 9 times 9 is 81. That gives us a final answer of 254.34 centimeters squared. The second part of this question asks us to find the circumference. So our circumference formula is circumference equals 2 times pi times the radius. Keep the 2, 3.14 for pi, and then my radius is 9. Multiplying all these together, and I get a final answer of 56.52 centimeters. Question 13, if you use a protractor, remember to line it up on this point and then your line here. It's an acute angle, and I got it when I measured it with a protractor on my paper. I can't measure it with a protractor on here, I don't have that ability, but it measured to be about 55 degrees. Question 14 is asking me to classify the 4 angles. So I have I have 3 classifications. I have right angle, which that equals 90 degrees, acute being less than 90 degrees, and obtuse being greater than 90 degrees. So if I look at angle A right here, it looks like it's 110. That's greater than 90 degrees, so that's going to be obtuse. Angle B over here, 60, that's less than 90, so that's going to be an acute angle. Angle C is at 100, that's again bigger than 90, so that's obtuse. And then lastly, angle D is a 90-degree angle, and that's otherwise known as a right angle. Question 15, it gives us the figure below. It says the measure of angle 1 is 4x, and the measure of angle 2 is x minus 5. It wants us to find these angle measures. So the reason I wrote them there is because I can look at those 2 angles together, and I know that when I add those angle 1 and angle 2, I should get 90 degrees because of this right angle right here. So I'm going to add these 2 angles, but I know that angle 2 I can count as x minus 5, and then I can also add angle 1 to that, which is 4x. Together that'll equal 90. So we just solve this equation. We're going to solve for x, and then we'll plug our x back into those individual equations here to get our individual angles. So if I combine my like terms here, I have 5x minus 5 equals 90. I'm going to add 5 to both sides. Leaves me with 5x equals 95. When I divide by 5, I'm left with x equals 19. So once I find x for 19, I'm going to plug that back into this equation here and this one up here. For angle 2, if I take 19 minus 5, that leaves me with 14 is angle 2. It's my measure for angle 2. And then for angle 1, I'm just going to take 4 times 19. And 4 times 19 is 76 degrees, so that will be angle 1. 14 degrees for angle 2. Question 16 is asking me to find the values of x and z. First thing I'm going to do, I'm going to work with one variable at a time. So the first variable I'm going to find is x. And the reason I'm picking that one is because I know when I take this angle here and this angle here and add them together, so I put them together, they form my straight line. They are supplementary to each other. They add up to 180. So I'm going to take 8x minus 36 plus 12x minus 42 and put that equal to 180. So when I combine my like terms, here I have 20x and then negative 38, it should be a 38 there, I'm sorry. Negative 38 plus negative 42 is a negative 40, or negative 80, excuse me, I'm having trouble here. Negative 80, and that's equal to 180. Then I'm going to solve this for x again because it's just asking us to find the values of x and z. And add 80, add 80. And that leaves me with 20x equals 260. Divide by 20, divide by 20, and I'm left with x equals 13. So I can put that up here, x equals 13. Now it's asking me to find z. Well, z is a vertical angle to this angle over here. So I'll mark it in blue this time. So I know I can find z if I substitute in 8, and for my substitute in x, 13 for x, and take away 38 from that. That gives me 104, take away 38, and you're left with this angle equaling 66 degrees over here. Vertical angles are congruent, so because this angle's 66 right here, this one is also going to be 66, so that leaves us with z equals 66 degrees. Question 17 is asking us to find the volume of the rectangular prism. This formula is volume equals length times width times height. In this case, it doesn't matter what you use for the length, the width, and the height. It's all 8. So we're just taking 8 times 8 times 8. And that gives us an answer of 512 feet cubed because we are finding the volume. Question 18 is asking us to find the volume of the rectangular pyramid. That formula is volume equals 1/3 the area of the entire base, so the area of this rectangle at the bottom, times the height. That's 1/3. Again, this is the area of the base, which is, again, length times width, so we're going to take 9 times 7 times my height, which is 5, so that's 1/3 times 63 times 5. A third of 63 is 21 times 5, or you can type all of this in your calculator. You could do 1 divided by 3 times 63 times 5, and that will give you a final answer of 105 yards cubed. Question 19 is asking us to find the volume of a sphere, and that formula is V equals 4/3 pi r to the third power. Again, this is on your formula sheet, so just fill in what you know. 4/3 times 3.14 times 7.3 to the third power. When you simplify this, you should get the following. And when I multiply those all together, I get a final answer of 1,628.7 millimeters cubed. Again, most of the parts of this, of the second part of the final exam review is just knowing your formulas and plugging them in. So again, not necessarily knowing your formulas, but which ones to look for on the formula sheet and then plugging in your information from there.